So welcome back. I'm Alan J and welcome to Lincoln Central with your 14th amazing trig tutorial in the Basic Trig series. You might notice some differences in the presentation of this video and succeeding ones. The move is towards a more personal touch with the use of handwriting. You'll also see the mouse pointer making an appearance from time to time to indicate parts of diagrams and equations. And it all goes towards making the teaching that much effective. Another upside will be greater productivity, more videos for you to watch. Anyway, I hope you like the changes and agree with me that it is an improvement. Just to warn you though, we are getting to the more difficult end of the Basic Trig series, so the pace will pick up from now on. Back to the work in hand. In this tutorial, we'll be visualizing what the sine rule is and doing some simple problems. So let's start with drawing a triangle. Any triangle. The sine rule works with all types. I'll be labeling the angle values by capital letters with the length of opposite sides in small case. Starting with an angle of capital A degrees and the opposite side of length small case a, we go to an angle of capital B degrees and the opposite side of length small case b, and finally an angle of capital C degrees and the opposite side of length small case c. The scene is set, so let's write out the sine rule definition. The ratio of each side to the sine of the angle opposite is a constant. Okay, so let's call this constant small case k. Then, using the symbols for the sides and the angles in the triangle, we get small case a divided by sine capital A is equal to k. Small case side b divided by sine b is equal to k. Small case c divided by sine angle c equals k. The ratio of the side to the angle is the same in each case. A over sine a equals k, b over sine b equals k, and c over sine c is equal to k. Now, eliminating the k by making the equations equal to each other, it follows that a over sine a is equal to b over sine b, which equals c over sine c. Problems with the sine rule are fairly straightforward, but you need to know how to change the subject of an equation. Essentially, there are just two problem types. The first is you're given two sides, one opposite the angle, and one angle is required. The other type is you are given two angles and one side, the side is opposite one of the angles, and one side is required. Example number 1. In a triangle, a 31-degree angle has its opposite side equal to 15 centimeters. If one of the remaining angles is 65 degrees, what is the length of its opposite side? Answer to 2 decimal places. In the triangle, we have the 31 degree angle and the 15 centimeter opposite side, the 65 degree angle, and the unknown length x. First, we state the rule using the sine rule and immediately put in the numbers for the sides and the angles. 15 divided by sine 31 degrees equals x divided by sine 65 degrees. And if we now cross multiply, that's the bottom multiplied by the top and the top multiplied by the bottom, we get x sine 31 degrees equals 15 sine 65 degrees. A linear equation, so now we can easily isolate x. So rearranging, we divide each side by 31 degrees, this cancels on the left, leaving the x alone. X equals 15 sine 65 degrees divided by sine 31 degrees. This gives 15 times 0.9063 divided by 0.5150, which equals 26.3971. Now to 3 decimal places this would give 397 at the end. To 2 decimal places the 7 rounds the 9 up to 10, which makes the 3 into a 4. So here we have the answer. Opposite side x is equal to 26.40 centimeters to 2 decimal places. Example number 2. In a triangle, a 62-degree angle has its opposite side equal to 17 centimeters. If one of the remaining sides is 13 centimeters, what is the size of the angle opposite? Answer to 2 decimal places. Here we are, there's a 62 angle and opposite side 17 centimeters. We have 13 centimeters and we have to find angle theta. As before, the first thing to do is to state the rule. Okay, here we go. Using the sine rule and substituting the values for the sides and the angles, we have 17 divided by sine 62 degrees is equal to 13 divided by sine theta. Okay, cross multiplying, we get 17 sine theta degrees is equal to 13 sine 62 degrees. Okay, putting the sine theta on its own, it's dividing both sides by 17, we get sine theta is equal to 13 sine 62 degrees divided by 17, which equals 13 times 0.8829 divided by 17. And this comes to 0.6752. So our angle theta is equal to sine minus 1, 0.6752. So that means sine minus 1 means the angle has the sine of 0.6752. Okay, so that comes to 42.4697 degrees, and we need this to 2 decimal places, so we eventually end up with theta equals 42.47 degrees. And that's all, folks. The next tutorial will examine the cosine rule with even more worked examples to help you get the hang of it. Anyway, thank you for watching. Oh, and don't forget to subscribe. You don't want to miss the latest vid. See you soon.